Welcome, dear students. Numerical Practical 25 Modified Euler's Method by C Programming. Modified Euler's Method, Problem 25. Write a C program to solve the following initial value problem by modified Euler's method to find the value of y for x equal to 0.1 up to 0.5, increment 0.1, correct to 6 decimal places, and dy dx equals to fxy, and this 1 plus xy plus x square into y square plus x cube plus into y cube whole to the power 3 by 2 whole divided by 1 plus x square into y square whole to the power 1 by 2, and y 0.1 equal to 1.1 plus r by 10. R is the last digit of your C roll number. Now, modified Euler's method, consider a first order ordinary differential equation dy dx equal to fxy with the initial condition yx0 equal to y0. Fxy is a given function, either maybe linear or non-linear, and this is also an initial value problem. This modified Euler's method is a single step method, explicit method for solving ordinary differential equations. It is also known as predict or corrector method. For solving the ordinary differential equation 1 by modified Euler's method, we have to find the approximate values of y at equispaced points x1, x2, xn, where h equal to xn minus x0 by h. N is the step length. Integrating 1 from x0 to x1, we get integration y0 to y1 dy equal to integration x0 to x fxy dx. Now this equals to y1 minus y0, so integrating this is equal to h by 2 fx0 y0 plus fx1 y1 by trapezoidal rule for integration. Here y is a function of x, so obviously y1 this equal to at the point x1 equal to y0 plus h by 2 a at the point x0 y0 plus a at the point x1 y1. Clearly y1 depends on itself, so we find, because this is left hand side y1 depends on y1, so we find the initial approximation of y1, the initial approximation by the Euler's formula, and this is the y10 equal to y0. This is 0 indicates the initial value, initial iteration, initial approximation. This is equal to y0 plus h into f at the point x0 y0, and substituting this initial approximation of y1, that is y10, in the right hand side of 2. So right hand side of 2 is this y1. We get the first approximation of y1 as y11, this in the index y1 within brackets, the first approximation of y1, this y0 plus h by 2 f x0 y0 plus f x1 comma y1 0. So k plus 1th approximation of y1 written as y1 k plus 1 equal to y0 plus h by 2 f x0 y0 plus f x1 y1 k. In general, we write this is the y at the point I plus 1 initial approximation 0 equal to yi plus h into f x x f x I yi, and yi plus 1 for the approximation for the iteration k plus 1, this is equal to yi plus h by 2 f xi yi plus f xi plus 1 comma yi plus 1 k previous iteration or k, and this is the predictor formula, and this is the corrector formula. I runs from 0 1 to n minus 1 and k runs from 0 1 to and so on. And stopping criteria is the modulus value of yi for k plus 1 approximation minus yi kth approximation is less than epsilon, where epsilon is positive quantity, is a desired level of accuracy. The modified Euler method uses the average of the slopes at 2 points to estimate the value of the function at the next point, whereas Euler's method only uses the slope at the current point. So this is the geometrical interpretation of this. This is the actual curve y equal to fx, that is equal to this y equal to yx. At this point, this a0, say this is the x0 and this is the x0 y0, this point, and draw a tangent. This is this. This point is say x1, so this is the step length h1. So this point, so actually by Euler's method, so this point is the approximate value of this y1 by Euler's method. This height is y1. This is y0 plus h into y dash 0. And at this point we again find the value this s2. This is the function f of x1 comma y1 k iteration. This is the slope s2. Now this slope s1 and this slope s2, at this point the average of this slope is this s1. So the s is the average slope of s1 and s2. So this is the half into f x xi yi plus f xi plus 1 yi plus 1 k. That is the average slope. So we draw a line parallel to this line s to this ac is the slope parallel to s line. So this ac point is the modified Euler's value at the point x1. This is the modified Euler's value, which is nearer to the exact value. This point b is the exact value. So modified Euler method, we get the more uh, correct value to this, and this is the geometrical meaning of this method. Now this is the modified Euler method. This function, this is the this function. First we define this function, and then this is the enter the last digit of your roll number, and this is the x0 is the x0 here. This is the x0 equal to 0 point x0 here 0.1. X0 is 0.1 and corresponding input r. So y0 equal to 1.1 plus r by 10, and age equal to 0.1 also, and xn equal to this is the final value of x is the 0.5, and age equal to 0.1 this, and this is the step x equal to x0 plus h if x is less than equal to xn, and print the x, and yp is the p for predictor value. This y0 plus h into f x0 y0. Actually this is we calculate the initial value from the Euler's method, and yc for the corrector value, that is y0 plus h by 2 f x0 y0 plus f x yp. This yp the before step at this stage yp, this yp is the predictor value is this. And so we write this. And while the absolute value of yp minus yc greater than the error term, error epsilon, that is here we choose here 0.00000001, and then yp equal to yc. So predictor value of y is the corrector value of y, previous corrector value of y c, and the new corrector value of y yc equal to y0 plus h by 2 f x0 y0 plus f x yp x yp. And print this character value yc, and print new line, and next new x0 equal to this x, this x0 plus h, and y0 equal to yc is the character value. Go to one step, go to the step and print this and this, enter. First we save this and save, compile and run this problem. So this is the modified Euler method. Input the, say r is the last digit of your roll number, say 0, initial value of x0, say this equals to, according to our problem, x0 equal to 0.1, and this is the initial value of y, this y0 equal to 1.1. Enter the final value of x n, say 0.5 here, according to our problem. This step length according to our problem 0.1, and so this is the x and corresponding fx. So this the initial x0, this is the corresponding y0, that is fx0, and this point x1, and this is the improved value, modified value. This is the predictor character predictor, and this is the ultimately at this point 0.2 is the ultimate value, is this 1.222519, and corresponding x2 0.3 is the final value, is this 1.373217. At this point 0.040 equal to value is 1.578564, and 0.50 actual value is the 1.913614, is the value of the function fx at the point corresponding 0.5. So thank you for watching this video.